Now we're going to write an equation of a quadratic given a graph of it. In order to do that, we need the vertex, and we need some other point that our graph goes through. It can be any ordered pair that we know the graph is going through. So our vertex, where our U-shape ends, is right here at -3, -4. There's our vertex. And then we can choose any point that we know this graph is going through. So I can tell my graph is going through 0, -1. I could also use -6, -1. Those are the only two that are really obvious this graph is going through. I'm going to use 0, -1. I like to use the y-intercept most often because it just makes the numbers a little bit nicer. The equation of a quadratic in vertex form is y equals a times x minus h squared plus k. Just like before, when we were given the points, we're only going to plug in things for x, y, h, and k. We're keeping a as a. Here our y value is -1. Then we have a times 0 minus -3 becomes 0 plus 3 squared. And then minus 4 on the outside. I'm going to add 4. So now we have 3 equals a times 0 plus 3 is 3 squared. 3 equals a times 9, divide by 9, and simplify, we get 1/3. So then our equation is y equals 1/3 x minus -3 becomes x plus 3 squared minus 4. Let's look at one more where you're given a graph. Here our vertex is at -2, 6. And my y-intercept is 0, -2. Again, you don't have to use the y-intercept. I just think the numbers are nicer. You could definitely use -4, -2 if you like that better. Solving for a, when we substitute things in, we have -2 equals a times 0 minus -2, which is 0 plus 2 squared plus 6. Subtracting 6, we get -8 equals 0 plus 2 is 2 squared, which is 4a, and dividing by 4, our a value is -2. So then our equation is y equals -2 times x plus 2 squared plus 6.